This is Pamela Smythe from the University of Waterloo. I'm one of the hosts of Beyond the Bulletin, the podcast of internal communications at the university. We bring you news and views from the Waterloo community. Please spread the word that we're on soundcloud.com or wherever you get your podcasts. And now the interview from episode 162 of Beyond the Bulletin, originally broadcast on October 13th, 2023. We have probably all seen video or images of marine life entangled in fishing gear. It's a leading cause of death for endangered whales. When they were undergraduate students in the Faculty of Engineering, the team behind WhaleSafe came up with a possible solution. It's a rope-on-demand system for use in crab and lobster fishing. As Jake Chateauneuf, now a graduate student in the Department of Mechanical and Mechatronics Engineering, tells us, their idea is making waves in all the right ways. Jake, welcome to the podcast.
Yeah, thank you for having me.
WhaleSafe is a system that stops whales from getting entangled in ropes that are part of fishing gear, specifically gear for lobster and crab fishing. What's at stake?
Yeah, so I guess there's an environmental and economic side to it. So for the environment, whales are becoming entangled, and this is something in rope, and this is something that has occurred more frequently in recent years. There's a stat from the from NOAA, which is the National Oceanic and Atmospheric Administration, that says that there's 368 North Atlantic right whales remaining. They estimate 58% of human-caused deaths are from entanglement, and they believe 85% of North Atlantic right whales have been entangled at least once. So because of this, the federal government and also the American government are proposing legislation for ropeless or rope-on-demand fishing gear. This is currently slated for 2024, but this was originally pushed back from 2023 since there's a lack of solutions. For the economic side, of course, fishing is it's like a way of life in the Maritimes and also in the Pacific. The market size for lobster, there's about 600 million, and there's about 10,000 fishers. Most of these, from 45 fisheries, sorry. So most of these fisheries, they're owner-operated, and these changes will be more expensive, and they will take longer.
What changes?
The legislative changes. If ropeless or rope-on-demand fishing is enforced, this will make the fishing process longer, and it'll make it more expensive because of the cost of the components. And since the fisheries are owner-operated, this cost is put back on the fishers. So there's I say there's a lot at stake, of course, for whales. We don't want whales to get entangled, but we also want fishing to be economically reasonable.
How did you come up with this idea?
This was originally a capstone project, and the capstone team, we've been working together since first year. And I guess for various projects, we always seem to make something that's water themed or something that has magnets in it. So originally we were brainstorming some ideas over the summer. We had people on our team that are from the East Coast that they know fishers, and they noticed that these legislations were being proposed, and we noticed that some of the changes could have a big impact on how fishers operate. So we wanted to design something that would help the fishers, but also would help whales with not getting entangled in fishing equipment.
I didn't realize that getting entangled in fishing gear was killing northern right whales. I thought that ships were hitting them.
Yeah, so there's actually about the remainder from human deaths are from vessel strikes, and I think a lot of the reason why the deaths have increased is because they're migrating towards areas that are they're migrating towards the fishing areas. They're not traditionally there weren't whales there, but because of climate change, they've changed their patterns and they're interfering with fishing boats and fishing equipment.
How does your system work?
I'll start with how lobster fishing currently works because I think a lot of people aren't familiar with it. So basically, there is a set of traps. Fishers will have a set of traps on a line. These could be 6 to 8 traps, depending on the jurisdiction. The traps, they're about the size of a hockey bag. Basically, the fisher will push the traps off of the boat, and they sink to the bottom of the ocean. And they have a buoy that floats on the top of the ocean, which is probably about the size of a backpack. And there's a rope that connects the buoy to the traps. And basically the fisher, when they go to get the lobster, like go to get the catch, they grab the buoy and then they haul in the traps with the rope. The problem is the rope hangs in the water and it could be in there for up to 24 hours depending on the catch. And this is where whales are getting entangled. So our solution basically removes this vertical rope and stores it underwater with the traps. So our device, we're planning to make it about the same size as a lobster trap, and we want it to be launched off the same way. It contains a spool with rope that floats to the surface when it's activated. The spool is attached to a magnetic latch, which is enclosed with the electronic components, and our acoustic system, like the acoustic system's in with the electronic components. And this is attached by rope with the traps. So basically the fisher pushes everything off, and they'll have a computer on board, and they'll be able to log the coordinates on the computer. And when they return to retrieve the catch, they will use the computer to locate where they release the traps. They'll send out an acoustic signal. This signal is picked up by our device at the ocean, and the signal activates our latch, and this causes the spool to unlock and float to the surface. And from there, the fisher can grab the spool and haul in the device and traps like they normally would.
Wow, rope on demand it's called. Brilliant.
Basically, our system, the rope would be in the water for a few minutes rather than a few hours. So it reduces the likelihood of entanglement.
What a great idea. How do the acoustics work?
So basically, the fisher will send out a signal from the boat, and our device, it has the ability to receive the signal and send out the signal as well. So when it receives the signal, it will release the latch. And we use a piezoelectric transducer for this. This is commonly used in other underwater acoustics applications. We chose this based on the range. The acoustics have the longest range.
And that's how they find the device? I mean, it's accurate. It's not going to be a mile away.
If a fisher releases the traps, it's not going to fall vertically, like perfectly vertically down to the ocean floor. So our idea is we're hoping to have an acoustic signal range of about half a mile or 805 meters. So the idea is when the fisher is within that range, they'll be able to pick up where the traps are, and then they can send out the signal and it should be picked up so that the buoy can float up to the surface. Yeah, if it's within a half mile, of course it won't float up vertically either. It might float somewhere else. So once it floats to the surface, it should be within like half mile, maybe a mile, and they can be able to locate it visually.
Now, is the signal it emits whale safe?
So we looked at volume and also the frequency of whale communication. So for volume, we found a NOAA paper that says that volumes above 150 decibels cause behavioral disturbances in marine life. So our signal is below that. And we also found that whales communicate at about 30 hertz to 8 kilohertz. So our signal, we've designed it to operate at 20 hertz or 20 kilohertz and 25 kilohertz. It's an 8-digit sequence, and it uses 2 sets of tones. Each sequence will be unique for a device, so you don't accidentally release another person's traps.
Is it in use right now?
Not right now. We are currently redesigning some of the components. Right now, we're actually upgrading our acoustic system to include a piezoelectric transducer. For our capstone project, we had a limited budget, so we went with just like a regular acoustic system. So we're working to include that with our funding. And we're also optimizing the magnetic latch configuration, so we're redesigning it to make it a little smaller and stronger without saturation. And we're redesigning other components to include these changes.
Well, the team did win the Velocity 5K pitch competition.
So that's one source of funding there. And I think it showed that our group could work together and address a real world problem that could be recognized outside of engineering.
I know you're still tweaking, but how is what you're planning with whale safe different from what's already out there? Because rope on demand systems already exist.
Our system is different because we have a magnetic latch to hold our spool in place, which is different from burn wire that is used by most competitors. It doesn't produce metallic waste like the burn wire method. We also, with our communication system, we want to prevent trap tangling. So you'll be able to see, we're hoping that you'll be able to see like competitors' traps within your range. Sometimes like if like you can overlay your traps over someone else's, and if the ropes get tangled, then you can't, like nobody can get anything. You can't pick up either one. So that's something we're hoping to prevent with our system. And we also want to develop the acoustics such that it goes to the range of lobster and crab fishing. For lobster, that's about, it could be shallow waters or up to 400 meters depth. For crab is usually about 100 to 800 meters. Whereas a lot of the acoustic systems used by the competitors, I believe they go for a longer range, and that makes them more expensive. One of them, they're charging like 5,000 US for their system. So we're hoping, I think for us, we're hoping to be about like 2,500, 3,000. Currently, fishers are fishing with the old method. Right now in Canada, they have to use weaker rope. The fishing rope used to be like 3,500 pounds strength, and now it's about 1,700 pounds. And this means that it snaps more often, and this can be dangerous because it, like when it snaps, like the boat can feel that force, so like the boat can rock, and it's like an unsafe working condition. Plus, it's also expensive because like when the rope snaps, like they lose their catch, like they lose money from that. Plus, there's waste of the ocean. So yeah, a lot of the competitors right now, they're not adopted by fishers just because like they're really expensive, and it'd be like more work for them as well. Plus, like if they don't have to change right now. So like right now, like the weaker rope is like a more cost effective solution.
Do you think your technology could be used for the ghost gear problem?
Yeah, I think down the road it totally could. Right now, we're focused on making rope on demand fishing gear for fishers. But yeah, that's definitely something we could do down the road with our acoustic system.
When you learned that you had to do this capstone project, did you immediately say, let's do rope on demand? Or how did this idea evolve?
Like we, I guess, had to pick something in the first couple of weeks, so we bounced around some ideas, and we eventually decided on like whale safe fishing. As for the rope on demand itself, we originally had like a morphological chart, and we made some sketches. Basically, the morphological chart, you list out like different functions and then like different ways to achieve that. For the latch, we thought of like magnets or burn wire, stuff like that. Yeah, from there we prototyped different components. For the magnetic latch, I did the simulations for it. So I simulated like the pull force with different magnet arrangements. And then for prototyping, we created a magnetic circuit, made it into a latch, pulled some different weights with it to see how like strong it would pull.
What kind of learning experience was the whole capstone process?
Yeah, capstone was interesting because I think for a lot of our old design courses, like you're kind of told like what the process is, where you should be, what to do. So the capstone, it was a lot more open ended. So basically, we called just shots. We were responsible for like picking our topic, I guess following a schedule, like keeping documentation. So I think it was like definitely a lot more involved. Like with the concepts, like we definitely learned a lot about magnets and acoustics.
Well, you said you guys like magnets. What is it about magnets that you like so much?
Oh, they're magical. Yeah. Also with the design process as well, like we got to learn about the design process and like actually like go through an 8 month design process rather than like usually in a course it's like maybe 2 or 3 months.
Did you have any ideas when you started this that this could be a company or that even maybe before you came to Waterloo that you would be an entrepreneur?
Yeah, so I guess when I came to Waterloo, like I did like the school tours and stuff, and they Waterloo, I think at the beginning they mentioned their intellectual property policies and how it's like unique from other universities. So basically, they let you, like, if you create something, it's your idea. And at the time, I was like, all right, cool. But yeah, I think by the time we got to capstone, it was, we wanted to make something that we were interested in, but also we wanted to have the option to make it a product. We thought that like there is a need for rope on demand fishing gear for the fishers, but also like for the whales, for their sake. And we thought we saw that there weren't many solutions on the market yet, and with the at the time regulations coming into 2023, we wanted to have something that could be like we wanted to have an idea that could be like rolled out with the regulations.
What kind of response have you had from fishers?
During the design process, we consulted with them, like basically just asked like what would they like to see in a rope on demand system, and we tried to include their comments in our design.
Well, it worked because you won the Velocity 5K pitch competition in March, and most recently the team was national runner-up in the James Dyson Awards. Congratulations. For those who don't know, it's an award for current or recently graduated engineering students to encourage them to realize their problem-solving ideas.
For Dyson, I think it shows that like our design, it's well thought out and it's meaningful. This is something that we can include for like future competitions or grant applications. With the Dyson competition, so because we got national runner-up, we are through to the next stage, which is where they take the top 3 from each country. There's about 30 countries in the competition. And they take the top 3 of each country and they narrow down the list to 20. And the top 20 are judged by James Dyson, and he picks a winner, which the winner, I believe, gets £30,000, which is about 50 grand Canadian. And there's a sustainability winner as well. They get the same prize, and the international runner-ups get 8 grand as well. The grand prize would be in the middle of November. They created a web page for us, so if you go to like the James Dyson Award website and look at 2023 entries, you can find Whale Safe there.
Cool. Well, we'll put a link to that in our show notes so people can check it out. What are your future plans for it?
Yeah, so for the short term right now, we're just like refining the design over the next few months. Hopefully, like by the time we get a design that we like, we want to go out to the Atlantic and conduct some sea trials next summer. As the longer term, if the like once we're happy with the design, we want to set up like a head office or a manufacturing facility out in the Maritimes, and we want to like build and sell our device to fishers.
It's so exciting and such an important development. All the best to you, Jake. I'm looking forward to seeing what happens next. Thanks for being here.
Yeah, thanks for having me.
Thank you for listening to this interview from the Beyond the Bulletin podcast from the University of Waterloo. You will find our archive of full episodes on the University of Waterloo website. Select interviews are on the university's YouTube channel. Just look for our playlist there. Please join Brandon Sweet and me for new episodes. And don't forget to tell your Waterloo connections about us.